All right, chapter 7 deals with finding or working with right triangles. So, the very fundamental thing about our right triangles is you learned last year or possibly the year before that about Pythagorean's theorem. Now, you learned it as a squared plus b squared equals c squared. This is going to be the last problem that I allow you to do writing it that way. Right? Technically, and we'll get into it in the definition, and I'll talk about why it'll help you here, because in 7.2 it'll really help you out if you write it the correct way. Right? But for what you've done so far, this theorem works perfectly well written this way. So we know that A and B, they are the two legs of your triangle. So it doesn't matter which one's which, they are interchangeable. So if you want to write it as 5 squared plus b squared, or a squared plus 5 squared, it'd be completely up to you. Equals, C is the important one. C is always opposite of your 90-degree angle. So in this case, C is 13. Right? So technically in this problem, my B is X. So 5 squared is 25. 13 squared is 169. So we subtract our 25 over. We get x squared equals 144. To solve, to get rid of that squared, we just take the square root of each side, giving me x to equal 12 as my missing side then. Right, we're going to get into, as I said, 7.1, 7.2. They're going to deal with this idea of Pythagorean's theorem and how we can work with it. In Pythagorean's theorem, right, when you go through and you find that missing side, if all three sides are whole numbers, it is known as a Pythagorean triple, such as what we just found in the opener of 5, 12, and 13. So a Pythagorean triple is a set of three positive integers that satisfy Pythagorean's theorem. If you notice when it comes to Pythagorean's theorem, it is written a little bit differently here. And there's a reason for that. This is actually how Pythagorean's theorem is described. And it is going to be how we use it from this point forward. C squared is what goes on the left-hand side. The a squared plus b squared goes on the right. It won't make a difference right now. However, when we get into 7.2, it will really make your life easier. Now, when we deal with Pythagorean theorem only works in one type of triangle. It only works in a right triangle, which is a triangle that has one right angle. In that right triangle, your legs of your triangle are the sides that are adjacent to the right angle of your triangle. So they are A and B here. And once again, those two legs are interchangeable. It doesn't matter which one's A and which one's B. If you want to instead call this B and call this A, that's perfectly fine. As long as the side that goes opposite your 90-degree angle is your C. That side is known as your hypotenuse. The side opposite the right angle of your right triangle. Now, the other thing to keep in mind, that hypotenuse is your longest side. It's opposite the biggest angle, so it must be the biggest side. That brings us to Pythagorean theorem. In Pythagorean theorem, the way the theorem is actually written, it says the square of the hypotenuse. So that is our c squared. That's what comes first. The square of the length of the hypotenuse, c squared, is equal to the sum of the squares of the legs. That's the a squared plus b squared. So from this point forward, we are writing it not the way we have been in the past. We are going to be writing it as c squared equals a squared plus b squared. So let's take a look at our first example here. It says find the length of the hypotenuse of our right triangle. So c squared equals a squared plus b squared. In this case, c, the side opposite my 90-degree angle, is x. A squared and b squared are interchangeable. You can do 7 squared plus 24 squared. You could have done 24 squared plus 7 squared. Either way is perfectly fine. So we get x squared equal to 7 squared is 49. 24 squared is 576. Add them together. We get x squared to equal 625. So to solve our equation, we take the square root of each side. We get x to equal 25. Notice these are 3 whole numbers. This is another example of what they call Pythagorean triple. Right. Same thing here, finding that length of our hypotenuse. C squared equals a squared plus b squared. In this case, x goes in for c again. A we'll call 9, and b we'll say is 12. Oops. So x squared equals 9 squared is 81. 12 squared is 144. Add them together, we get x squared equal 225. Last thing to do is take our square root. We get x to equal 15. Right, take a look at example 2 here. It's not always going to be the variable that goes in for our hypotenuse. It's not always the variable that goes in for C. It says a 6-foot door rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. It says exactly how high above the ground is the doorknob. So you can see the little triangle over there that's created, where this is x, this is 5, and this is 6. Once again, Pythagorean theorem says that c squared will equal a squared plus b squared. C is our 6 this time. A squared, we'll call it x. That means b squared is 5. Once again, x and 5 are interchangeable. The key is 6 had to go in for our x value. So right now I got 36 equals x squared plus 25. We'll subtract our 25 over. So we get 11 equals x squared. And now we take the square root of each side. Here is where we have to be careful. In the directions, they say that they want to know exactly how high it is. That does not mean to take the square root of 11 and get 3.3166247.9. It does not mean to do that. It does not mean to round it. What it means is I take this x equals the square root of 11 and I try to reduce it. I try to see, are there any perfect squares that go into 11? Well, my only perfect squares to look at are 4 and 9. Neither of those go into the square root of 11, so we are done. That is the answer. We leave it just like that. All right, let's take a look at our next example. This is a 5-foot board now. Rests under a doorknob. And the base of the board is 3.5 feet away from the bottom of the door. Approximately how high above the ground is our doorknob? So very similar problem to what we had just done. Set it up the same way. C squared equals a squared plus b squared. C here in this case is 5. The a and b are interchangeable. This time I'll do 3.5 squared plus x squared. 5 squared is 25. 3.5 squared gives us 12.25. So now we'll subtract it over. We get x squared on the right. We get 12.75 on the left. And then to finish, we take the square root of each side. So we have x equals the square root of 12.75. Now, if you look at the directions here they do say approximately how high above. So now we can take that square root of 12.75 and round our answer. We get 3.57 then as our rounded answer. Remember, your rule of thumb is to round to 2 decimal places unless they specify otherwise. Right. For example 3 then, it says find the area of our isosceles triangle with our side lengths that are there. 16 meters, 17 meters, 17 meters. So, in order to find the area of a triangle, area is 1/2 the base times the height, or base times height divided by 2. So, our base here is 16. Remember, the key is a base and a height must intersect to form that 90-degree angle. So we got to figure out our h. So we'll pull out a right triangle to work with. Here's h, here's 8, here's 17. So we have 17 squared will equal 8 squared plus h squared. 17 squared is 289. 8 squared is 64. Now we'll subtract it over. We get 225 equals h squared. So then finally we take the square root of each side. We get our h to be 15. So there's our height. Our height we just found to be 15. So we get 1/2. The base, the whole base here is 16. Our height we just found to be 15. So 1/2 of 16 is 8. 8 times 15 is 120. Looking at your units, everything is in meters. So my answer is 120 meters squared. Right. Take a look at example 4. It says find the length of our hypotenuse of our right triangle. So once again, just filling in. C squared equals A squared plus B squared. C in this case is the side opposite of 90 degrees. So in this case, it's X. A and B are interchangeable. I have 24 squared. I have 45 squared. So 24 squared gives us 576. 45 squared gives us 2,025. Add them together, we have x squared equals 2,601. Then we take the square root of each side. We get x to equal 51. Right. Last one here then is finding that area. Remember, area is 1/2 that base times the height. Or that base times height divided by 2. Once again, we know our base. Our base is 28. Since I did the 1/2 base times height last time, I'll do the base times height divided by 2 this time. Our base is 28. Our height we still need to figure out. So this is where I need to come in with my height and work with just one of those right triangles. So the hypotenuse here is 50. My bottom side is now 14. The height is what we need. So we have 50 squared equals h squared plus 14 squared. $50 squared is 2,500. 14 squared is 196. We'll bring our 196 over. We get h squared equals 2,304. So then we take the square root of each side. We get h to equal 48. So we had a base that was 28. We now have a height that is 48. So it's 28 times 48 divided by 2. 28 times 48 is 1,344 divided by 2. Gives us an area of 672. And in this case, we have feet squared then. All right, that brings us to our homework then. Pages 436 to 438, the numbers you have there.